Now potential energy of a dipole in an external field. આ આપણે બે રીતે ગણી શકીશું, રાઈટ? તો એ બંને મેથડથી આપણે અહીંયા કેલ્ક્યુલેટ કરીએ. First method, in that we will calculate the total work done to place the dipole at some angle theta with the field. અને સેકન્ડ મેથડમાં આપણે જે આગળ થિયરી ભણ્યા એનો જ યુઝ કરીશું, કારણ કે ડાયપોલ એ બી આફ્ટર ઓલ સિસ્ટમ ઓફ ટુ ચાર્જીસ જ છે. ઓકે, ચાલો. Now see, suppose as shown in the figure, we have external uniform electric field E, and in that a dipole is placed at some angle theta with respect to electric field. Angle of the dipole means angle of dipole moment, which one is always represented from negative charge to positive charge. So angle of dipole moment with respect to electric field, that is theta. Now in chapter number 1 we studied this thing. When the dipole is placed in electric field E, the torque acts on it, that is P cross E. So we can write the magnitude of the torque, that is PE sin theta. Now, if we want to rotate the dipole in this field from angle theta 1 to angle theta 2, then work done by the external torque, આપણે external torque apply કરીને એને rotate કરવી પડે, કારણ કે field જે છે એ જે torque લગાવે, under the effect of it dipole always field ને align થવા try કરતી હોય. એટલે આપણે જો એને theta 1 angle થી rotate કરીને theta 2 angle ઉપર ગોઠવવી હોય, then we have to give some external torque. So work done by external torque to rotate the dipole from angle theta 1 to theta 2, that is W equal to integration theta 1 to theta 2 tau external d theta, torque that is PE sin theta. So we can write integration theta 1 to theta 2 PE sin theta d theta. Clear up to this one? Now W, that is equal to, take PE outside the integration, then integration sin theta d theta, that is minus cos theta, and now limits theta 1 to theta 2. So first substitute theta equal to theta 2 upper limit, then minus theta equal to theta 1 lower limit. So we can write the work done W, that is PE minus cos theta 2 minus cos theta 1. Therefore W, that is equal to PE into cos theta 1 minus cos theta 2. And we know this thing. This work done will be stored in the system in the form of potential energy. So we can write the potential energy U, that is equal to PE cos theta 1 minus cos theta 2. Clear up to? Now suppose here we consider theta 1 equal to pi by 2. And now from that position, if dipole is rotated by angle theta, so we can take theta 2, that is equal to theta. Then the potential energy that we can write PE cos pi by 2 minus cos theta. Therefore U equal to minus PE cos theta. So that is equal to minus P dot E. It implies that now in general we can write, when dipole is at any angle theta with respect to the field, then its potential energy, that is minus Pe cos theta. Clear? હવે આપણે potential energy of a dipole in external field એ આપણે જે થિયરી ડિસ્કસ કરીને એ પ્રમાણે ડિસ્કસ કરીએ. કારણ કે આફ્ટર ઓલ ડાયપોલ ઇઝ અ સિસ્ટમ ઓફ ટુ ચાર્જીસ. હવે ડાયપોલને તમે જો એક્સટર્નલ ફિલ્ડમાં મૂકો તો એવું કહી શકાય કે સિસ્ટમ ઓફ ટુ ચાર્જીસ ઇન ધ એક્સટર્નલ ફિલ્ડ. તો પછી એની પોટેન્શિયલ એનર્જીનું ઇક્વેશન તો આપણે હમણાં જ ડિરાઈવ કર્યું કે U ઇક્વલ ટુ Q1 ઇન્ટુ V એટ R1 પ્લસ Q2 into V at R2 plus K Q1 Q2 upon R1 2. Clear? Now for dipole, Q1 that is Q and Q2 that is minus Q. So we can write Q1 that is plus Q, Q2 that is minus Q, and here when we substitute Q1 that is plus Q, Q2 that is minus Q, then we can write minus KQ square upon the distance between these two charges, that is 2a. For the dipole it is 2a. So we can write potential energy, that is Q into V at R1 minus Q into V at R2 minus minus K into Q square upon 2a. Now here first step, for that take Q common. So we can write Q into V at R1 minus V at R2 minus KQ square upon 2a. But see this bracketed term, that is nothing but the potential difference between position 1 and 2. So simply we can write this is equal to Q into delta V minus KQ square upon 2a. But we don't have delta V, but we have the relationship electric field E, that is equal to minus delta V by delta R. So we can write delta V that is equal to minus E delta R. Now see here, when the dipole is at an angle theta, then when we move from charge minus Q to charge plus Q, then in the direction of the field, the displacement, that is 2a cos theta, because if this angle is theta, then here this angle that will be also theta, and this one is 2a. So we will get the change in potential in the direction of electric field for distance 2a cos theta. So we can write delta V that is minus E into 2a cos theta. Now substitute value of delta V in this above equation. So potential energy at angle theta, that is equal to minus Q into E into 2a cos theta minus KQ square by 2a. But Q into 2a, as per definition, that is that is P. So we can write resultantly minus PE cos theta minus KQ square by 2a. But see here, for any position of the dipole, this KQ square upon 2a, this term that is constant one, and therefore that particular term is insignificant. So if we neglect it, again we will get the same equation for the potential energy, that is minus PE cos theta, or we can write minus P dot E. Clear?